Stellar Energy by Zoe Gleeson. The first figure is a diagram of the amount of solar radiation hitting the Earth. The lines on the diagram represent solar radiation. There are 13 segments that are divided from the North Pole to the South Pole. The segments are labeled with letters. The table shows the number of solar radiation hitting the segments. In this column, it is the segments, and in this column, it is the number of radiation lines. Each segment had a number of solar radiation lines. The graph is all of the data based on the table. Each of the bars is one of the segments. Like, for example, the first green bar is segment A through B. The yellow bar is segment C through D, and so forth. The ultraviolet light energy from the star HR 8799 is a type of light energy that gives sunburns. This is because it is a main intense factor within it. The figure at right shows that ultraviolet light is intense, so it would most likely cause a sunburn. Ultraviolet light is damaging to the cells in your body. In conclusion, you can get a sunburn from the star HR 8799. Based on the figure at right, I believe that the star HR 8799 emits more energy than our sun. HR 8799 has higher intensity with the ultraviolet light energy. The ultraviolet light energy is dangerous for the intensity to be so high, because ultraviolet light is the energy that causes sunburns. Based on the graph, it shows that HR 8799's intensity is way higher than our sun's. And our sun is already very powerful. So if you look at the diagram, HR 8799's intensity is way higher than our sun's. Ultraviolet light is a factor, but it is visible, and infrared energy are stronger in the star than our sun's too. HR 8799 and our sun are very different in many ways. The differences between each star are shown in the figure. Our sun and HR 8799 each have certain energy peaks for the curves and the three light energies. With infrared visible and ultraviolet, the star HR 8799's peak is located in the ultraviolet light. Our sun's peak is located in the visible light energy. The diagram at right helps me understand that the distance from the sun and Earth doesn't change. And that showed me that distance isn't the reason we have seasons. The orbit of the Earth and other planets are circular and is nearly a perfect circle. Because the orbit is a circle, the radius and distance from the Earth to the sun stays the same. Therefore, this diagram showed me that the orbit of our Earth is a circle, and that is why our distance from the sun doesn't change. The statement, "Today was sure a cold winter day," as Earth orbits the sun, winter occurs when the Earth is farthest from the sun. This statement is incorrect because, as I explained in the last slide, the Earth's orbit stays the same. The Earth's distance from the sun to Earth stays the same because the Earth's orbit is nearly a circle. So the radius and distance stays the same. The angle of the sunlight hitting Earth causes seasons, such as winter and summer. So, if you look at the diagram at right, the sun is shining directly on the southern hemisphere and not directly on the northern hemisphere. Therefore, in the northern hemisphere, it would be winter. In the figure below the top figure, it would be fall in the southern hemisphere and spring in the northern hemisphere. This is because the sun shines directly on the northern hemisphere and southern hemisphere. In the next diagram, it would be winter in the southern hemisphere and summer in the northern hemisphere. This is because the sun shines equally on the northern and southern hemisphere. In the next diagram, it would be winter in the southern hemisphere and summer in the northern hemisphere. This is because the sun is shining directly on the northern hemisphere and not directly on the southern hemisphere. In the last diagram, it would be spring in the northern hemisphere and fall in the southern hemisphere.